Hello and welcome to today's class. For today, we are still discussing about an important concept under integration known as definite integral. In our previous class, we have discussed about definition of definite integral and the form of definite integral and also how to solve problem involving definite integral. So let's take one example under definite integral, as you can see below. The example says, given upper limit of pi over 4 and lower limit of 0 of the integral of what tan squared x dx. If I'm told to find if I'm told to integrate this, what do you do there? First things first, this is a question on what? Definite integral. Why? Because I have my upper limit and lower limit. So that's why I know that this question here is a question under definite integral. Now, what's the first task here? We said to solve any problem under definite integral, what do you do first? Your first task is to what there? Ignore the limit. So my first task here is that I will ignore this limit. I'll have that the integral of what there of tan squared x dx. So the idea is that I want to integrate tan squared x. Now look up please. From here, I can easily integrate tan squared x here. You know why? Tan squared x means tan x times tan x. So in that case there, I'll be using integration by part, right? So I can use by part here. But at this point here, recall something please. From here, recall that we said 1 plus tan squared x is equal to what? Sec squared x, right? From trig function, 1 plus tan squared x equal to sec squared x. This means that, look up please, I'll make tan squared x subject. I'll have that tan squared x is equal to sec squared x minus 1. This 1 moves here becomes minus 1. It means that anywhere I see tan squared x, I'll put the value of what? Sec squared x minus 1 there. So it means that I will replace this 1 here with what? Sec squared x minus 1. So I'll have that the integral of sec squared x minus 1. Next up, I have the x. Obviously, from here, I will solve this one here using the general method of integration. So I'll take my integral, multiply the integral symbol with this one, then attach the x to it. Similarly, multiply the integral symbol with 1, and next up, attach the x to it. From the idea of general method of integration. If you don't know about the concept of general method of integration, I'll kindly drop a link in the description of this video. So check out for the description of this video. You see a link that will teach you or take you to a page on how where I discuss about integration using general method. All right, from here I will take the integral symbol, this man here, with what? With sec squared x, attach the x to it. Next up, I'm seeing minus sign, minus, multiply the integral symbol again with 1, and next up, and the x. I have this. I've expanded this bracket here. So what's my next task here? My next task says that if I integrate sec squared x, I'll have tan x, right? So if I integrate sec squared x with respect to the x, I'll have tan x. Minus, if I integrate the x, I said in our previous class under integration, if I integrate the y, I'll have y. If I integrate the x, I'll have x. Similarly, 1 times the x is simply the x. Integrate the x, I'll have what? The x. I'll have x. Next up, plus c. This plus c is called the constant of integration. So we said in the last class under integration, I'll drop a link on the last class under integration. We said in the last class that putting c is what? Optional. Why? Because at the long run, it will cancel out. So in other words, I will ignore plus c. So I'm having this as my answer after integrating this one alone. Now, no, don't forget that we ignore our limit first. So at this point here, I will introduce my limit. So open a square bracket. I have the answer to be here is what? I have tan x minus x, right? Next up, introduce your limit. Your limit. I have pi over 4 here, and I have 0 here. So I showed you how to go about this, right, in our last class. So how do you solve this? First task, pick this one. I have tan x minus x, right? Next up, take the upper limit with this one, pi over 4, minus this same thing here. That's tan x minus x into what there? 0. So this means that anywhere I see x here, I'll put what? Pi over 4. Anywhere I see x here, I'll put 0. But first is first, but before I proceed, what's pi over 4? Pi is simply 180 degree over 4. My answer there will become what? 45, right? So pi in calculus, right? Or perhaps under geometric stuff is what? 180. But pi in normal mensuration, circle, sector, the stuff, pi is simply 3.142. So, but in this case here, it's 180. So anyway, I see pi over 4, I'll put 45. So in other words, I'll have that tan, what's my x here? X is simply pi over 4, which is what? 45. Tan 45 minus what there? X is what there? X is simply this man, which is what? 45. I have this here. Minus into tan x is what? Tan 0 minus 0. Here. Next up, my first access to do what? Simplify this. If I punch tan 45, I'll have 1 minus this 45 here into minus into tan 0 is 0 minus this 0 here. I'm here. Similarly, from here now, if I simplify this one more better, I'll have that 1 minus 45, right? I have this. Next up, minus 0 minus 0 is what? Is simply 0. So from here, 1 minus 45 is what? Minus 44. Next up, minus 0. My answer becomes what there? Minus 44 after integrating that question. So this is how to solve a problem under definite integral.